Hello student, in this video I am going to continue from the last video. We are discussing about forecasting methods. Now there is also one very important topic associated with forecasting, that is causal models. Often leading indicators can help to predict changes in future demand. For suppose like housing starts. Causal models establish a cause and effect relationship between independent and dependent variables. So there will be two variables, one is independent, one is dependent variable. So causal model establish a cause and effect, means one will cause and one will affect. Mean due to the cause of some event, independent event, due to the event independent occurring of this even independent variable, then the dependent variable will get the effect of the independent variable. A common tool of causal modeling is linear regression. A common tool of causal modeling is linear regression. Additional related variables may require multiple regression modeling. So here you can see we have already gone through the linear regression in one video previously. Identify dependent y. Here y is the dependent and independent x variable x. Linear regression equation y equal to a plus bx. Solve for the slope of the line. We need to find the slope of the trending line. V equal to summation of xy. Whatever the xy we have, xy minus n into number of points n into x mean y mean divided by summation of x square minus n x mean square. Solve for the y intercept. A equal to y mean minus b x mean. So develop your equation for the trend y equal to a plus bx. So that is dependent variable y, and there might be any error difference between actual value and regression value, and these are the actual values. And this is the line equation y equal to a plus bx. So you need to find b first, then only you can find the value a. So you can find a b by using this equation, then finding the value of a, you can get the y equal to a plus bx to find the trend line. So here you can see a maker of golf shirts has been tracking the relation between sales and advertising dollars. Use linear regression to find out what sales might be if the company invested 5300 in advertising next year. So here sales is here in this is the column for sales, this is the column for advertisement, x. So that is the thing is that advertising cost, and this is the independent variable advertising x, dependent variable sales, one, these are the y variable. So what is the xy multiplication of these two, and what is the x square? The x square of this is the x square, and what is y square? This is y square. So we'll need to find b, summation of all xy, then minus n. Here you can see average of x is 47.2, that is 4, n is 4, number of 4 samples, n is 4, average of x is 47.25, average of y is 147.25, and summation of xy is 28202 divided by 9253, that is x square means this is the x, total x, okay, summation of x square. So summation of x square means you can square this all this one, that is this one, so square of this one will be 9253, and this is n, that is mean square, 47.2 whole square, 4 into n is 4, so that is it. So we can find b equal to 1.15. so a equal to y minus b x mean, so 147.25 minus 1.15, 47.25, so a equal 92.9. so y equal to a plus bx. So now 92.9 plus 1.15x. Now we can put x and y. So this is the equation for the trending line. So in that way we can find the y value for every value of x. So next, this is the fifth value. If we put 53, then we can say that the value might be around this. This is the fifth value. So correlation coefficient, how good is the fit? Correlation coefficient measure the direction and the strength of the linear relationship between two variables. The closer the R value is to 1, the better the regression line fits the data points. So we know that this is the equation for Pearson correlation, R equal to this one. So you can, if you put the values of x and y from the previous table, you will find R equal to 0.982, which is close to 1. If you square it, R square equal to 0.98 square is 9.964. So coefficient determination, that is R square, measures the amount of variation in the dependent variables about its mean, that is explained by the regression line. Values of R square close to 1.0 are desirable. So again, some parts of multiple regressions are here. So I'll try to go through this again, through this topic. So I'll continue that part in next video. What I'm going to say is that before going to this another part, please try to execute this type of problem with different variables or different data to understand how we can go for regression. It is a linear regression. So how we can go for multiple regression for same type of data, and you can try to execute this the same thing using some programming technique like C or any program, simple program. You can do the regression analysis, because here you can see we can predict this value 1.53.85 if you give the independent variable 53. So point is that the prediction value will be this one, but actual value might not be this one. There might be some differences. So try to execute this one again, try to do the whole problem again, and also try to find out the correlation coefficient measure and correlation determination measures. It measures the amount of variation in the dependent variables, amount of variations in the dependent variable about its mean, that is explained by the regression line. So values of R square close to 1.0 are desirable. So that's it. So if you find any difficulty to understand this topic, please let me know. I'll try to resolve that over Google Meet. Thank you.